How do interrupts ensure immediate device response in embedded C? Imagine you're playing a game and suddenly someone calls your name. You stop what you're doing instantly to answer. That quick reaction is similar to how interrupts work in embedded systems. When a device needs attention, it sends a signal called an interrupt request to the microcontroller. The microcontroller then pauses its current task and jumps to a special routine called an interrupt service routine. This routine is designed to handle the device's needs quickly and efficiently. The key here is that the microcontroller doesn't wait around checking if the device needs help. Instead, it listens for signals and responds immediately when needed. This is what makes embedded systems so responsive and capable of real-time operations. When an interrupt occurs, the microcontroller first finishes the current instruction. Then, it automatically saves its current state, including registers and the program counter, so it can come back to where it left off. After saving its state, it jumps to the specific interrupt service routine linked to that device. This routine runs fast to handle the event, like reading data from a sensor or sending a message. Once the routine is done, the microcontroller restores its previous state and continues with the main program as if nothing happened. This process is supported by an interrupt vector table, which holds addresses of all the routines for different devices. When an interrupt occurs, the microcontroller looks up this table to find the right routine. If multiple interrupts happen at once, the system uses priorities to decide which one to handle first. Higher priority interrupts can even preempt lower priority routines, making sure the most critical events are addressed first. Some microcontrollers also allow nested interrupts, meaning an interrupt can be interrupted by a higher priority one. This makes the system even more responsive. The hardware automatically saves and restores the system state, so the programmer doesn't have to do it manually. In embedded C, interrupt service routines are written as special functions with specific syntax to tell the compiler they handle interrupts. To keep the system running smoothly, these routines should be short and fast, so the microcontroller isn't away from the main program for too long. This setup allows devices like sensors, buttons, or communication modules to trigger immediate responses. Whether it's controlling motors, reading sensor data, or managing communication, interrupts make sure the system reacts instantly. In summary, interrupts in embedded C give devices the ability to alert the microcontroller instantly, which then responds with a quick, dedicated routine. This system relies on interrupt vectors, priorities, nested handling, and automatic state saving to keep everything running smoothly and efficiently.